Alrighty, today we're talking about mole conversions. So the first thing to understand is what is a mole. A mole is a unit in chemistry. So the key thing to remember here is that 1 mole is going to be equal to 6.02 times 10 to the 23rd particles. Remember that particles, molecules, and atoms are interchangeable in this case, in these situations. So we're going to be talking about conversions. Whenever we're doing conversions, you need to set up the no-think method. So let's do an example. First example is how many atoms of mercury are in 7.3 moles. So what we know, we have started with 7.3 moles. And my smartboard's not working. This is not new. So we start with 7.3 moles, and we're trying to get 2 atoms. Remember, if I'm going too fast, you can pause it, write down the example, and then do it with me. So you always start with writing down what you're given, 7.3 moles. Then we have our times and a line. Now, because this is a conversion, we want to get rid of moles, and our end goal is going to be atoms. So we know that there are 6.2 times 10 to the 23rd atom in 1 mole. So that's the conversion factor we're using. So we're going to put moles on bottom in this instance because we have moles on top. We want moles to cancel out. So 1 mole is going to go on bottom, and 6.02 times 10 to the 23rd atoms goes on top. Then we can plug this into our calculator and get our answer. Now be very careful when you're plugging it into your calculator that you plug it in correctly. 7.3 times 0.02. And the correct answer, make sure that you get this as well, is 4.394 times 10 to the 24th atoms. So that's the first part of this conversion, going from atoms to moles, or going from moles to atoms. So if you have this example, where we start with atoms, 2.31 times 10 to the 22nd atoms, and then times in your line. This time we're going to go the opposite way. We're going to put 6.02 times 10 to the 23rd on bottom, so that way our units cancel out. 6.02 times 10 to the 23rd atoms is 1 mole. And our atoms cancel out. We're left with moles. Plug it into our calculator. 2.31 times 10 to the 22nd divided by 6.02 times 10 to the 23rd, and that gives us 0.38. Sorry, 0.038. I'm going to go ahead and rewrite that so you guys can see it a little bit better. Equals 0.038 moles. Alright, so those are the setup from moles to atoms and then atoms to moles. Second part is molar mass. When we're talking about molar mass, we care about the grams per mole. Now we can find this information, grams per mole, on the lovely periodic table. I'll do one example and then we will move on our own. Move on. So, what is the molar mass of sugar? We're going to do this one because we did this one in class. Let's go back. So this one was in class. we will do it in class tomorrow. What is the molar mass of sugar? So we have C2H12O6. It's not the correct molar mass of sugar, but this should be C6. There's a lot of typos in this one, I'm sorry. So we have C6. So we know that the molar mass of carbon is 12.01 grams per mole. Now there's 6 carbons, so we gotta times that by 6. We know that for hydrogen, it's 1.008 grams per mole. And we have 12 of those, so we're going to multiply by 12. And oxygen is 16 grams per mole times 6. We're then going to add all these up and get an answer. Now, if you do not want to show your work like this, that is fine. If you would like to just do it in your calculator, that is alright with me. And we get a total molar mass of 180.16 grams per mole. So that's how we calculate molar mass. All of these numbers came from periodic table. Make sure you check your periodic table to calculate molar mass. So we'll do one example where we go from moles to grams. Sorry, we go from moles to grams. So how many grams are in 2.5 moles of carbon? So as always, we got to start with what we're given. We have 2.5 moles of C. It's very important to write down your units correctly. I'm using this moles of carbon. Later on when we do stoichiometry, you'll understand why I have carbon there. Have your times and your line. Now, we know that mole is going to be on the bottom. We want to get rid of moles, and our end goal is grams of carbon. So that's our end goal. So we know moles is going to go on bottom, and grams is going to go on top. So that way, moles of carbon cancel out. Now we got to figure out this ratio. We know that we do this by looking at the periodic table. You look at the molar mass in the periodic table, and there's 12.01 grams per 1 mole. Let me plug this into our calculator. That 2.5 times 12.01, and that gives us 30.03 grams of carbon. So that's how you do a moles to grams. We're going to skip this one. We're going to do it in class tomorrow or the next day. Now we're going to put it all together. So we have the question, the example, how many grams are in 2.43 times 10 to the 23rd particles of CH4? So the first thing we need to figure out, how many moles there are. So we need to go from particles to moles. So we're going to start with 2.43 particles, CH4, times in your line. And our end goal is grams of CH4. So that's our end goal. Oh, I forgot a step. not really a step, I forgot something that we were given. This should be 2.43 times 10 to the 23rd particles. Sorry about that. I'm trying to go quick, make these videos quicker, and I'm just making them longer. I apologize. So, this is going to be a two-step problem. We have particles on top, so we know particles is going to go on bottom. What we can convert particles to, we can convert it to moles. So let's go ahead and do that. So 1 mole on top, and 6.02 times 10 to the 23 particles, CH4. So now we have moles. Now there's one more step. Their end goal is to get to grams. How do we get from moles to grams? Well, we use our molar mass. Times, in another line, we're going to have 1 mole CH4 on bottom, and grams CH4 on top. Now we got to figure out how many grams are in 1 mole. This is where molar mass comes into play. Carbon has a molar mass of 12.01 grams per mole, and hydrogen has a mass of 1.008 grams per mole. However, there are 4 hydrogens, so we got to multiply that by 4. Then we're going to add these together, and that gives us 12.01 plus 4 times our molar mass, 16.04 grams per mole. So we take this 16.04 and we plug it up here. Now let's make sure our units cancel out. We have particles on top here, particles on bottom there. Cancel out. Moles of CH4, moles of CH4, cancel out. We are left with grams, so we're good to go. Now we can just plug this straight into our calculator. The numbers on bottom we divide, the numbers on top we multiply. So we'll do 2.43 times 10 to the 23rd divided by 6.02 times 10 to the 23rd, multiply by our molar mass, 16.04, and that is going to give us our answer of 6.47. Grams of methane. So that's putting it all together, going from grams all the way to particles. Now for the learning target check, you're going to be given grams, and you're going to have to go all the way to particles. So you'll see both types of problems. And that is it for mole conversions.